Welcome, everybody. This is the Rotary E-Club of Silicon Valley, and every week we bring you the stories of people who are making the world better in all sorts of ways, locally, globally, digitally, and we think that's pretty darn cool. We think cool is important. We think cool is the kind of thing that makes you say, wait, what are you talking about again? And wait, I want to tell a friend about that. I have this buddy who. We believe that there is a joy and meaning and cool that comes from serving others. And so if you are intrigued by that idea, check out Rotary.org to learn more about Rotary International, 1.2 million people and 36,000 clubs, or check out our club, which is at Rotary.cool. You really will find us there. We're a bit proud of that, just saying. Now, speaking of cool and speaking of making the world a better place, our speaker today is a scientist of I was reading the biography and just trying, what do I want to focus on? He's a scientist who has done all sorts of amazing things related to X-rays and metallurgy and just all sorts of things. I'm going to let him reference the relevant pieces of the bio. If you would like to read the description and bio in more detail before you watch or listen to this recording, feel free to pause what you got right now, check the page where you found this, and it all will be there. Ule, what a pleasure to have you. We are excited to talk about Hipparchus and star charts and all of these things, and we welcome you to the Rotary E-Club of Silicon Valley.
Thank you so much. I suppose I will share the screen now.
Please do.
Okay. Well, thank you. It's my pleasure to report on some very recent work on one of the great scientists of the antique with the name Hipparchus. The work is done with X-rays, and we are using a technique called X-ray fluorescence. And the X-ray fluorescence technique goes as follows: a powerful photon knocks out an inner shell electron, and when that is filled, the atom emits characteristic light with a specific X-ray color. And here you can see a spectrum of X-ray light, which is emitted in this process. Each element, and that's the important thing, each element in the periodic table has its own characteristic X-ray light. And here you see, for example, on the spectrum, we can see phosphorus, chlorine, calcium, iron, copper, etc. This was already noted more than 100 years ago. And we have developed a technique to measure these spectra and then bring a fine beam of X-rays onto the object which we are interested in. In this case, a palimpsest page, and then for each pixel record the spectra, and that gives us a map. So here I have a video. It basically, we are scanning this object, we are raster scanning this object, and we record the spectra of fluorescence light coming out. And by doing that, we can generate a two-dimensional map of each of the elements in that particular page. In this case, this is a picture shown on our early work, but we did that on a hidden page. We did this work in February at SLAC, which has one of those really great synchrotron sources, which produces very powerful X-ray beams. And the object was a lost star catalogue by one of the great Greek astronomers with the name of Hipparchus. He is considered the founder of trigonometry, but is most famous for his incidental discovery of the precision of the equinoxes. We don't know much about him. Hardly any of his original work is directly cited, but he was important. Here is a Roman coin commemorating him. That you can find drawings and pictures about him. This is all fantasy. This is not something which we really know. But recently, in 2022, my colleague Victor Gisambert and his colleagues have found in a palimpsest page in a Christian biblical text hidden. They discovered 4 of the star coordinates by Hipparchus, and Victor listened to a talk which I gave 2 years ago, and we joined up, and he came with his team with these pages from the Museum of the Bible. They own this palimpsest book where Hipparchus' work is supposedly hidden, and they came with it to SLAC, and we were starting to use our imaging technique to look at it. This is where this is the St. Catherine's Monastery in Sinai, Egypt, where this palimpsest, this prayer book, was found originally, and this contains a lot of such hidden treasures. And here is a picture of one of the leaves, and we are interested not in the text which you can see on the top, but in some of the writings which are not visible to the eye and which have been erased and overwritten. When we started to do the X-ray, when we started to do the imaging, we found that in the calcium signal, we were mainly hoping for the iron signal, because we know these inks which were used to write these copies were iron gall inks. We found actually in the calcium signal, we discovered clear writings of Hipparchus, and what you see here is actually the undertext. The calcium signal shows a strong indication of the undertext. And we have now been able, and this is still ongoing, this is very recent, to identify 12 more star coordinates from Hipparchus in this book, in addition to the 4 which were originally published 4 years ago. The questions whether this was real or not have been settled now, and we are in the process, with this information, we are in the process of shedding light on the earliest history of astronomy, of Western, like Greek astronomy. Why are these star coordinates so important? Because Ptolemy, the famous Roman astronomer, used some of Hipparchus' star coordinates, but not all. And we don't really know to what extent their work is intertwined. So Hipparchus clearly was before Ptolemy, but we want to know is how does the work of those great astronomers relate to each other? We also had a few surprises, and I'm trying to move on. We found we found several drawings in this palimpsest of different star constellations. This is in the lead channel. We found the Corona Borealis, a beautiful drawing. Again, I'm struggling a little bit with the Zoom version of advancing. We found a Delphinus star sign in the lead channel. This is our X-ray fluorescence lead image. And then finally we found, and if you look at it, it's a woman with the 2 arms to the side, and you can see the head in the middle. So I'm drawing around it with my cursor. I'm not sure you can see my cursor, but you can see it. And this is actually the Andromeda star constellation. What did these images do in this palimpsest? Hipparchus star coordinates were used to augment, to make a very luxury edition of work on those constellations. These were done probably in the 5th or 6th century, and Hipparchus's work was a copy. Hipparchus lived before BC, about 2nd century BC, that was used to augment this. Here's the team. We have worked with the people from the museum. This is Rebecca Swardlow and Elizabeth Hazlett. You see Elizabeth right in the middle. Keith Knox and his wife Dale Stewart from Hawaii. They're imaging experts. Our friends at SLAC, Sam Webb and Nick Edwards, and Roger Easton from Rochester Institute of Technology, and then my two PhD students, Sophie and Minhal. And we are really, really excited about this work. We are now writing it up, and we hope to have a publication coming out probably either later this year or early next year. With that, I would like to thank you. If you're interested in this kind of work, I have a link to a review paper which shows extensive details about our work on cultural heritage. Thank you so much.
Uli, this is great. Thank you very much. Let's introduce the group that we have as part of the recording today. Uli, I'll have you stop sharing for a minute here. And let me have each person wave at the camera when I call your name. From our club, we have here in the Bay Area, Elton. Elton, good to see you, sir. Also in the Bay Area, Susan. From up in Vancouver, we have Nick. In Arizona, we have Dave. In Hungary, we have Victoria. Also in the Bay Area is Christopher. And we have two guests. We have Mahika of the Interact District 5170 and a friend of the club, Claire, up in Oregon. My name is Rushton. I'm in San Jose. And love that we get to share stories like this about advances in how we understand the past. Let's start with the member responsible for connecting us with you, Elton, who has a question. We're having a little bit of problem with Elton's audio, but please go ahead.
Okay. Yeah. Well, thanks, Elton. So Elton was asking what other objects we studied with this method, and also have others used it, and what the X-ray machines which provide these beams, other work which can be done with that. It's really, I mean, obviously to really answer it in full would take a long time. Short story, I have just been at a conference in Europe, in Sicily, and there are quite a few commercial machines now which are trying to do this. They don't have as powerful X-rays, but for certain objects like large paintings, this rapid scan X-ray fluorescence technique is working. I would also not say that we were the inventors of it, right? I mean, this goes back 100 years basically, and we have just shown with our work starting 20 years ago that this can be done realistically on objects. We have in the pipeline the Ptolemy palimpsest. So this is a really exciting one. It's from Milan. I need to, after this meeting, immediately I go back to another meeting where we discuss this. We have been imaging fossils a lot. We have done a lot of work on fossils because there's chemical traces of the original animal is often preserved in fossils. So by using this method, we can see, we can learn about the original animal which was fossilized by looking at the chemical signatures. And then finally, to the last question of Elton about looking at real-time chemical reactions. These are different machines. So what we are using is a synchrotron, and these other new machines are called X-ray lasers. They are even much more powerful, and they provide very short pulses. And those are the ones which we use to study chemical reactions in real time. We would not use that machine for valuable objects because the beam is so powerful that it destroys the sample in each shot. So there we need to replace the sample after each shot, and we can do these measurements because the pulses are so short. But these are also X-rays, and some aspects are similar, but it's a really different machine to do that work. So thank you. Yeah.
So a question that came in from Susan, which is a related topic, and this prompted from a New York Times article today. And today we are recording on June 30th, 2026. Page D2, D as in David. How to open mail sent 4,000 years ago, name of the post. And it describes X-ray computed tomography, which involves firing X-rays at an object and measuring how they are absorbed. Does this differ from multispectral imaging?
Yes. So thank you for that question. So there's a lot about the Pompeii, the Vesuvius explosion made this conservation of a lot of scrolls, the Herculaneum scrolls in Pompeii. And it's so interesting because the work which is now in the New York Times is my colleague from Tennessee who is doing this AI-based data processing to use CT scanning, which is a different technique than X-ray fluorescence imaging, to basically read what's in these scrolls. And there's an article from long ago in the New Yorker where I'm actually in it because we met at a conference, and I told this, he wanted me to do X-ray fluorescence. I said, no, you should use CT scans for that. And we are not doing it, but others are doing it. So I kind of guided him in this direction. I'm really proud of that. And he has been phenomenally successful. And I'm really happy to see that this work is taking off. Again, X-rays have different properties, right? And so certain things, a CT scan is basically the same idea as an MRI, just with X-ray. So it's a three-dimensional, you rotate the sample, you get three-dimensional information from the inside of an object. Our technique is a chemical technique. So we get information about what elements are in an object. Unfortunately, that technique does not lend itself well to three-dimensional objects. We can only focus more on quasi two-dimensional objects like a page or a flat fossil. And that's the main difference of those imaging techniques.
Well, it seems like a highly complementary approaches. Yeah.
Exactly. Yeah.
So, question from Victoria. Could you let's see, what is the starting point of the work? So was the starting point of this work when the professor from France contacted you, or were you working on something like this before that professor reached out?
Yeah, so this is a really important question also. The original work started with the Archimedes palimpsest. This was 20 years ago, and Elton might remember that. It was also the reason why I joined the Palo Alto University Rotary Club, because I gave a talk there. And then they said, oh, why don't you come more often? And so that's how I joined the club, actually. And ever since we did that work, and that was in the news. I mean, it was much bigger in the news than the current Hipparchus work. And we have been contacted by people who want to use this X-ray method to look at cultural heritage objects. And we have done quite a series of work. We have looked at an opera by Luigi Cherubini, which is at Stanford, and we basically added one part of an area to this opera media, which was erased. We have done work on a Galen, a Syriac translation of Galen. We have done basically like maybe a half dozen of other objects. And the way how this typically works is that people are interested, right? But there is a barrier to go to a big facility, and can it work and would it work, etc. And so that's how this one came about, that basically I was giving this presentation of all the work we have done and the expertise we have. And then Victor Gisambert, he said, oh, this is exactly what I'm looking for with the thing, because we still need to do it. And that's how it came together, right? It's really like a synergy of being at the right place at the right time, and then having the object and being able to bring that object, getting the support from the museum. That was very important. The museum said, yes, we are going to pay for it, right? We're going to pay for it to ship it to Stanford. We will bring 2 people with it, and that we could put it all together. And that's what we're doing right now with the Museum of Milan, that we can get this Ptolemy palimpsest. So the largest hurdle often in these extremely valuable cultural heritage objects is, can we get the object to the facility? Once we have that, we are in pretty good shape. We work with the Stanford libraries. We have a very strong team at SLAC to do the work, actually.
For a couple of details here, could you also describe for those listening or those watching what a palimpsest is?
Oh yes, sorry. So I'm using this expression. Parchment is basically sheep or goat skin, which was mainly used maybe from the 3rd to the 10th century or even 12th century. It is very expensive to get a whole book. You need basically to kill a flock of sheep, and then you have to dry the skin. And it's a lot of work just to get one book. So what happened in starting early, actually from the beginning, there were really traders, like used car salesmen, who would get books which were no longer of interest to the general public, and they would wash them, and they would actually sell them to the monks. The monks were busy writing prayers on everything. They would sell them, and then the monks would use milk or honey or lemon juice, lime juice to wash them off and recycle them and write their prayers on them. And what we actually think is the reason why we see the calcium signal is because when you write in the original parchment, you damage, it's kind of hydrophobic. It has like an oily surface, but when you write in it, you damage that. So when they washed it with milk, we think a little bit of the stuff in the milk got hung up in there. And the calcium we see now, we believe, and it's actually from the milk which was used to wash off the ink from the monk who then used this recycled parchment to write the prayer book on it, right? And that's like really one of those remarkable things. So inadvertently, they have conserved those older writings. And the similar thing was true with the Archimedes palimpsest. All of his work was lost, but this one work, which was meant to be erased, made it, because those prayer books ended up in monasteries, and in monasteries they could survive because they had storage was fine and everything. And that's how we get these. There are tens of thousands of palimpsests. Palimpsest is Greek for scrape again, straight and right again in the world. And many of them, we have no idea what treasures are hidden underneath. And hopefully with our work, we can in the future still reveal some more of that. Yes.
I love the combination of history and science on this for sure. Christopher asks about this kind of work related to things that are in popular culture and people tend to have heard of. The Dead Sea Scrolls, for example. Have you or colleagues worked these similar techniques on those, or is that a mismatch in terms of timing?
No, absolutely. So the Dead Sea Scrolls were the Dead Sea. My colleague Keith Knox, who is and Roger Easton, who you saw on my last slide, they have worked on the Dead Sea Scrolls. So this is a community of people. They know each other, and we know of each other, and we know where to go and what to find. It's still it's a relatively small community, I would say, but I mean, obviously it's growing. And as I said, museums are very interested in our technique because, when you look at chemical elements, you can see a lot of the great artists, the great painters, their canvas has some other paintings underneath, right? And they all have different metals because paint uses different metals. And so by using this X-ray fluorescence imaging making elemental maps, you can see of the paintings below, for example, even some of the great masters, the Dutch ones, and you can still find Rembrandt, for example. There are paintings underneath some of the famous Rembrandt paintings, and with this XRF, you can actually bring them out.
In terms of the history, there is finding something and there is looking for something. And as I understand it, with Hipparchus, it is that historians knew there were a number of writings, very few of which had survived by themselves. And so, you look at Ptolemaic writings or something like this, and that there's something out there. Do you go into this kind of thing with the thought, this is likely to be one of the things we are looking for, or are the discoveries accidental?
I think it's a combination. So when the Archimedes palimpsest was discovered, this was 1905 by this Danish scholar. He was in a small library in Constantinople, now Istanbul, and he found it almost coincidentally. And then he put his teeth into it and he started to take photos and try to said, "Oh my goodness, this is a copy of work of Archimedes." By the way, none of the original papyrus works have survived. So we are always talking about copies, but we are talking about very early copies, right? And so in the case with Victor, one of the things I should point out, like his work, when he published his work in 2022, there has been some controversy. There has been which I think has been, from what I heard, has been settled now. Some people said, "I don't believe that this is real." Right? I don't believe that you really found this Star Catalogue. I have a different interpretation. So it's not always like right away. By the way, our work now having 18 more coordinates will complete. I mean, it was, as far as I heard from the scholarly debate, it was already settled before, but now our work will, of course, make it much more solid. And so the bottom line is, you do, as an X-ray scientist, right? I cannot possibly find these objects. You need to work with scholars. And that's why, for example, your presentation in your Rotary Club is so important, because I can tell you, unlike my other research, which all goes through meetings of specialists who meet like a few times a year. Most of my cultural heritage work has been promoted through actually more popular press. I've been contacted by people after they read articles in the news, and because it's a much wider, much broader community, right? So I think that what you're doing, hopefully a lot of people will sign into this podcast, and that's the way how we find new collaborations.
Well, I certainly agree that the more people that share the video and the audio, the better, for sure. And essentially that comes down to the advice of people like Jobs, who said, "Stay curious," right? That there is a joy and meaning that come from serving others, and that is essentially based on a curiosity of what's possible. As we have, like a member of the Interact district here, and I am an educator of teens, as is Christopher and some others. What kind of advice would you give young people? I mean, you've had this experience of being a scientist of metals, right? And then you begin working collaboratively with historians. There are people who can point to religious scholarship and the work in Ireland of the monks who preserve things. There was the slide you had about the spot in Egypt. What advice would you have for young people that comes down to how to pursue what fascinates you?
Well, thank you for this question, and it's really a good one and an important one. I think it's important to know something very well and very deep, so that you become an expert, and you become an expert that you know it probably as good as anyone. You cannot just. Some people network stuff, but they don't really understand anything, and then they network it. But I think and that's the education you get, let's say college education or higher education. And then don't be too stovepiped, right? Keep your eyes open. Read, just the titles of Science magazine or National Geographic or the New York Times Science section or even other sections, and be open-minded, and you will find things. I could not believe in 2004. This goes back to 2004 when we proposed the XRF imaging of the Archimedes palimpsest. I could not believe that no one else in this big community of synchrotron had that idea. There was one person who proposed to do it, but not with the powerful X-rays, with weaker X-rays. No one else. And I said, how is that possible? It's so obvious that you should do that. And the reason is because most people, they just don't look on the outside. So have this, the T shape, like have the depth, but then don't restrict yourself from the breadth, because I can tell you some of the most rewarding experiences in my scientific career has been from working with people with very different expertises, and then bringing these teams together and collaborating and learning new things about other fields. I think, and if that's your philosophy, that should be like the philosophy, and then nothing can stop you.
I love that advice, and that is a good place for us to wind the recording down. So I will step in to say to all of you who are watching this video on YouTube or on our club page, remember Rotary.cool will get you to our site. Take a look at the top for the podcast series that you can find there. Our meetings archive, which shows you the breadth of interests that we have. Stay curious. And we hope that you will take an interest in joining groups of people locally where you are, or internationally where we are, such that we're able to together work and make great things happen for others. Uwe, we always like to hand it back to our speaker for the final word. So for those people who are finishing up the recording, what would you like them to have clearly in mind?
Just have fun.
Have fun is awesome. Awesome. Thank you so much. And thank you, everyone. We will see you next week.
Thank you.